Hello, I am presenting our multi-agent system for generating schema-compliant JSON from natural language for HR application. The challenge is enterprises need non-programmers to configure complex no-code platforms, but ensuring strict JSON schema compliance is difficult with standard language models. Our solution uses hierarchical orchestration and external schema enforcement to decompose structure generation into smaller controlled reasons steps. Let me explain our architecture. We use two-level hierarchical orchestration. There are two types of request. First, actions, simple procedures like updating employee records. The action orchestrator decomposes requests, routes subtasks to specialized action operators, which make two calls to generate JSON. Second, process, which are complex multi-component interfaces. These require an additional layer. The process orchestrator routes to the component orchestrators. One for tables, one for grids, one for forms, and so on. Each component gets a unique ID called OID, which allows us to track and merge components. The key idea is progressive restriction of the functional search space at each reasoning step. Let me demonstrate with a live example. I will ask to change the role of janitors to manager starting February 1st. Let's submit this action request. Then let's see how the system behave. So the action function is a tool calling named edit function, and this is the metadata that the agent uses to communicate with the orchestrator of action mode. So the output was successfully, and the answer, which is in Portuguese, says that the function of janitor was changed to manager starting 1st February of 2026. In the right panel, we can see the output of the agent. Now for a more complex example, which is process mode, we select here at the top of our chat the mode required. Then we can make the request. The process mode will create a complex interface object. So let's request a simple one first. That is the creation of an expense page list with a navigation bar. We are going to submit, and here we can see the message that was created by the orchestrator, which is composed by a task. The intention, that's create a new object, not update an existing one, and then the identification of this new object. Okay, this is our output. The expense pages with the navigation bar was created with success. So here we have the navigation bar that we requested. So we have the required fields, some buttons here. Okay, agreed with other informations. We are going to edit this object. So keeps the new expensive and export expense buttons in the navigation bar. Let's submit this request. So let's see. So need to update our object. So what is the intention? The intention of is now to update the existing object. So this is change, and we have our task here, and we are going to update an existing object ID that we saw before, the pageant agent 1. Okay, let's wait. Okay, here we have the buttons for new expenses and export expenses were kept in the navigation bar. So we have here our new object here. We have the new, okay, the new expense and the export expense here to report, okay, export expense, I'm sorry, here. Let's do another addition in our process. We going to create a filter for this visual object. So let's submit it and see how the system behaves. Here we have again to create a new filter, okay, but for the same object that we have before. And let's wait for update and see our filter, no filter. Okay, so the output was successfully, and here a filter for value was added to the page. Let's check here what where is our filter, and this is our grid that we had before, so we keep the old objects, and here our filter is here, filter for expense, and then we can have a new section in our object. The final JSON contains 3 integrate components: the page list, a grid, a filter, buttons, and so on, all properly composed with correct internal references. This demonstrates our hierarchical orchestration. The process orchestrate coordinate 3-component orchestrator: table, page, and grid, each managing their specialized operators. Attempting this with a single LLM call would likely fail due to schema complexity and component dependencies. Visit our GitHub repository to check for additional examples of prompts and requests, and explore how our hierarchical orchestration enables smaller models to handle complex structure generation tasks. Thank you.